Again, it's a rich thing.
What is going on, guys? Welcome back. In today's video we're going to learn how to synchronize Python threads using locks, so let us get right into it. Alright, now you probably know that Python does not support actual multi-threading because of something called the global interpreter lock. However, Python still offers the threading module and we can run multiple threads that work on the same resource. And if we have some downtime because, for example, we wait for a response or something like that, we have kind of the multi-threading effect. So the problem is, let's say I have a thread and this thread tries to increase a counter, then to do something in the meantime, we're going to simulate this doing something by just sleeping, so by just waiting. And in the meantime, another thread also changes the value of this resource, of this counter, for example. And then the first thread expects the counter to still be the same, but then it's changed, so we get inconsistencies. This can be a problem. When multiple threads access the same resource, we can get inconsistencies if we don't synchronize the threads properly. And today we're going to have a simple example of a counter class. We're going to have multiple threads calling a so-called count function or count up function. And we're going to increase the counter, we're going to sleep, which is going to be equivalent to doing some work, and then we're going to print the value of the counter. And you're going to see that without synchronization, the value is going to be a different one, and we don't want this to happen, and because of that, we're going to use locks to prevent that, to synchronize the threads. So let's get started by importing threading and importing time. Time is going to be used for time.sleep, and we're going to create a simple class called thread counter, and it's going to have a constructor in a init method here. Self.counter is going to be 0, and we're going to have a lock which is going to be threading.lock, but we're going to comment that out because we're not going to use it first, because I want to show you what the problem is. So let's use the count function here. We're going to say, okay, while true, what this function is going to be doing when it's called is it's gonna say print, actually it's gonna say self.counter plus equals 1. Then it's going to say just increased, or maybe we should have, let's add a parameter here to just have the thread number so that we know which thread is doing what. Thread number, whatever says just increased counter 2, and then it's going to be self.counter so that we know what the value is. And then we're going to say time.sleep. 1 second, this is going to be equivalent to doing some work, because even though we don't have actual multi-threading in Python, we have downtime of threads like sleep, for example, or waiting for a response to a request or some other thing. And in that time, other threads can work. So we're going to do that, and then we're going to copy that message, print it afterwards, and we're going to see that I'm going to say done some work, now value is. And that's essentially it. This is what we want to do. Now we're going to create an instance of that. TC is going to be threaded counter or thread counter. And then we're going to say for counter variable in range, and let's do 30 threads now. And let's go ahead and say t equals threading.thread. Target of this is going to be the tc.count function, and then just t start. Now I think this should work. Yeah, we need to pass the thread number, so args equals. Then we need actually the variable here. I'm going to pass I. And then you can see here, let's run this for a while. And essentially what you see here is that, let's find an example. It's going to be a bit difficult because we have too many threads. But essentially, let's see where we have a 1. Just increase to. Where do we get these colons from? I think maybe we should go with less threads because this is going to be confusing, or this is starting to be confusing. But essentially what you can see here is that when we look at some instance here like this one, or actually here, just increased counter to 27, done some work, now value is 30. So this is one example here. It's a bit chaotic because they're printing all at the same time, but you can see here that the thread with the number 4 started by increasing to 27. And let's say this time.sleep here, this work that we're doing, let me add here the comment, work we are doing. This work is still somewhat of an atomic operation. Not really atomic, but we want the counter value to stay the same. So we want to increase it, we want to process something, and then when we get here, we want this value to still be the same. We don't want another thread to do something in the meanwhile. Or in the meantime. So what we can do here is using locks in order to prevent that. Now, in this particular example, you're going to notice that this is like just not using multi-threading, doing things serially. And this is the case because, of course, we're not doing any work. But this doing the work may be something that we can do in parallel. So while another thread is doing something, maybe before that or afterwards, in parallel, we just have a section that is locked. So we don't have to lock the whole function. We don't have to lock every single thread doing everything. We just lock a certain section. For example, in this case, this is all we have. Because of that, it's going to look like it's serial, so it's not parallel. But if we choose that section to lock it, so we have to use a single lock to release, acquire, release, basically saying, okay, now I have the section. No one else can process this section. In order to do that, we can say self.lock.acquire and then self.lock.release. And of course, we need to create the lock here. And the effect of that is that this lock, and it has to be the same object. We cannot create a new lock for every thread. It has to be the exact same lock, otherwise it doesn't make sense. What this basically does is thread 1, for example, takes this lock and says, now I acquired the lock. Thread 1 now owns this lock, so to say, until thread 1 releases it. So if thread 1 never releases the lock, basically no one will be able to acquire it. Which means that thread 1 acquires it, does the work, no one can acquire it, and if you cannot acquire a lock, you basically wait. So thread 1 acquires the lock, does the work, and before it releases it, let's say thread 2 gets to that point as well, it tries to acquire the lock, cannot acquire the lock because thread 1 still has the lock. It waits here until thread 1 releases the lock, and then it can acquire it and proceed. Then thread 3 is going to try to do that, and so on and so forth. And because of that, we have the synchronization. We can see that this is the case. But you can also see here that this also leads, in this case, to just one thread working because, yeah, basically it doesn't happen fast enough. Maybe we can do something like self.or maybe time sleep random rand int. I don't know. Something like that. Maybe this is going to cause another thread being able to do something. There you go. But essentially, this is what happens. You make it more controlled because the problem here or the effect here is that you cannot there cannot be two threads or multiple threads being in that section at the same time. Only one thread can acquire a lock, and then it has to be released before another thread can acquire it. And this is synchronization because this means that no two threads can be executing that at the same time. And in particular, of course, this means that no two threads can be doing that at the same time. And also, while this is sleeping, no other thread can be increasing, and so on and so forth. Of course, you can also just go ahead and make the section shorter. In this case, we would not solve the problem that we talked about before, because this would only mean that no two threads can increase the counter at the same time. But it would not mean that the counter cannot be increased while the sleep. So this is important. Yeah, again, this is a quite trivial example. It's not a real life example, but the basic idea is that we can use locks to lock certain sections so that no two threads or no multiple threads can work in the same section at the same time. So that's it for today's video. Hope you enjoyed and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video, and